This is great. Okay, we now have Ilia and Stephanie talking about researcher IDs. Second last. Stay here. Okay.
All right, so I'm Ilia Tulchinsky. I work for Google Cloud, and I co-chair a researcher identity substream of Dury with Stephanie. We will attempt to keep you awake by having small amount of slides, and I will actually attempt a live demo somewhere towards the end. So hopefully this will be entertaining. So you heard, let me put this in the context very quickly. We heard about all of these APIs that enable discovery and research and new findings by having multiple nodes and being able to connect to multiple endpoints and multiple data sets. Well, in order for that to work, we need the APIs, but we also need to solve how we are going to access it, because a lot of those data sets are not public access, they're controlled access, or they have more complex access scenarios. And so Moran talked about the data use ontology terms, which is one half of the puzzle, being able to code data sets and describe your research purpose. Well, the other part of the puzzle is the researcher identity. It's the who you are. It's who you are and what you're going to do. So the who you are part is what we're focusing on. In the work, we draw a lot on the published work by Stephanie and collaborators on registered access. And we want to solve the authorization use cases for the global research community. So very quick problem statement, why it's hard. Well, we have a lot of players or a lot of classes of players in this field. We have multiple identity providers. Some of them are associated with research institutions, European as well as North American as well as others. We have identities that come from public cloud providers. Then we have the actual data side. We have data side repositories, access committees, and the actual researchers that want to access the data. And finally, we have diverse ecosystem of actual technical implementations in terms of how various APIs are implemented, whether they're sitting on cloud providers or private clouds and so on. And so, it's a bit of a mess and complicated. So the way we want to approach solving it is we like using a passport analogy. So passports are issued by different countries, but there are some nice features that passports have. Some of them are common attributes that you will find on pretty much each passport. So we know there's going to be a name, a date of birth, maybe eye color, your picture, and it's pretty easy to reason about those attributes when you're looking at a passport, no matter where it comes from. This is some of the things that we want to create here. We want to create the common language of attributes and claims about the researcher identities that can be presented by various identity providers or passport issuing authorities, and that then can be evaluated in a machine-readable way by resource owners or data custodians that ultimately own the API endpoints. And so we need to do two things to solve this. One is to agree on a set of standard protocols that we are going to use to transmit and represent these claims. And we're converged on OpenID Connect protocol, which itself is based on OAuth. And then the second thing that we need, which is where the bulk of the work is happening, is this standard language of claims. So what are the claims? Is it, bona fide researcher? Is it ethic terms? Other things, your institutional affiliation and roles. And this is where collaboration with driver projects matters a lot, because the way we derive those is by understanding what each of the driver projects actually needs to make these decisions. Very important to also state what we are not trying to do. We're not trying to come up with a single passport to rule them all, or a single centralized authority. None of this will ever work. This needs to work in a federated way where we have agreed language of claims. And where we are is we have a specification document that we are actively working on, as well as we have submitted a security document to a security group and working through a review. That's Stephanie.
Hi, thanks. So one of the main applications for our researcher identities claims standard is to enable a new data access model we've been working on over the last few years, registered access. And the goal of registered access is to improve and streamline access to data that require the acceptance of conditions of data access and use. So we've built consensus around what data access conditions, a generally applicable set of data access conditions would look like. And these are shown here. They're basic good data use practices for genomics and health data, meet local ethics requirements, keep the data secure, don't try to re-identify research participants. And the idea with registered access is to only register once as far as possible. So we also had to come to, to agree on, in broad terms, how a researcher should be registered and gain what we're calling bona fide researcher status, either through their institution or through another registered researcher. And this is where the researcher identity claims standard comes in. The demo is going to show how this works already for Elixir and in what we're trying to develop more broadly. But let's say you're a researcher in Europe, you've registered with Elixir, obtained bona fide researcher status. You can access Elixir's registered data resources. We'd like researchers to be able to use that identity and access other registered access systems. So that'll be shown in some detail. But before I hand back to Ilia, I want to give a big thanks to collaborators at Elixir and at Google for the Global Alliance allows us to turn policy proposals, which are basically ideas on paper, into real life solutions, and that can really make a difference. So yeah, it's a great pleasure to be involved in that.
All right, we're getting close to demo. So one more thing that I wanted to say is that so registered access is very important because of this property of being able to have some things like bona fide status and so on, and being able to access a lot of data sets in many scenarios. But we also know that there are going to be other scenarios like controlled access where that's not sufficient and you need more of those claims, like being approved for access to a specific data set or being on a specific whitelist. So I just wanted to mention that in terms of the language that we are developing, we want to make sure that it's rich enough to represent all of those types of claims that are required for different scenarios. So before I show the demo, I want to explain what's happening there. That's why you have an engineer here, so I want to bore you with architecture diagrams, but very quickly. So what we have is, first of all, what is the identity? So in this case, we are using a researcher identity that is using Elixir as an identity provider, and it's able to attest to bona fide status claim. And then on the other side, we have a demonstration of a data resource. In this case, we just, for demo purposes, took 1,000 genomes, but we brought up on top of it a controlled access, if you will, or registered access beacon API implementation. And what's going to happen is we're going to have a login through Elixir in some UI. We're going to make a request to a beacon API, which should fail if we don't, if we're not authenticated or we don't have bona fide status. And it should succeed if we have it. And so there is a configuration here that basically expresses the requirement to have a bona fide status in the language of GA4GH claims. And that configuration is going to be evaluated against the claims that indeed come with the identity. And if all works, then you get the read access and you are able to answer your beacon question. All right, so let's see if we can make this work. Okay. So this is the UI that shows kind of a beacon query. It's a particular variant that I think is associated with susceptibility to malaria. So I'm going to perform a search, and it's not going to work because we have a controlled beacon here, and I have not logged in, so I'm not authorized, and I did not get access to it. So now I'm going to go and do an Elixir login. And thank you, Craig, for setting up a test account, in case you're wondering why it's called Craig. All right, so I have now logged in Elixir, and I have an Elixir profile, and I want you to pay attention to this bona fide status, which I acquired as a researcher, so Elixir is able to attest to that. And so now that I'm going to make a call to the Beacon API, that status is going to be passed to it. So now I'm logged in, and I'm going to perform a search again, and it succeeded, and I was able to discover that indeed 1,000 genomes happens to have samples with this variant. So I'll close this now. Okay, so what's actually happening here, just to show some JSON, is that we have Elixir ID token, which is transmitting claims today in the language of Elixir. It's being translated into GA4GH claims, which is part of that draft standard that we are creating. And so this GA4GH researcher status bona fide is what gets evaluated against the configuration. Again, the idea here is that as a data source owner, you should be able to express your configuration in one language so that you don't have to learn about the intricacies of what claims might be coming from each particular IDP. All right, and so our next steps is we're going to use the demo as kind of our way of expanding and bringing in more IDPs with North American implementation as well, and not just the European one. We are working with driver projects, Elixir, all of us. You're going to see something was missing as well. We're going to work towards the approval of the standard and more real adoption by driver projects. And with that, I will hand it over to Mark to talk about another, continuing on this story, because I've showed you still a simple example of just using one identity provider, which is Elixir in this case, and Mark is going to make it more complicated.